object-oriented programming in PHP. Now, the general concept about object is that it is usually referred to as the instance of a class. Furthermore, there are certain general features of a logical class. For instance, encapsulation. This is the ability to control or own methods and functions that other objects cannot use or alter. Okay, because the original class and methods are meant for the parent, but it actually can be granted through the use of the access modifier public once it is used in the class. Now, when we get to the practical aspect of demonstrating this, we'll be using the human body as an example. The second part of object-oriented programming that must be grasped is abstraction. This is a kind of extension, or call it annex, to encapsulation. It provides necessities to class without granting access to the entire class methods. Now, in this category, we'll be using computer system, normal desktop system that is used for desktop purposes. Thirdly, inheritance. Closely related to biological genetics, it is referred to as ability of a class to transfer its functions and methods to another class for reusability. For example, the family cycle. Now, finally, polymorphism. This is the ability of a class to take geometric shapes through interfaces, which serves as share points. Okay, in this category, we'll be looking at extending the family cycle. Then, we should also bear in mind that a class property is, conceived as an adjective of noun. An adjective describes a noun. And conceptually in programming, these can have access modifiers like private, public, or protected. The private is much more restrained than the public, and the most restrained is a protected access modifier. The other thing we should also bear in mind is that methods and functions are syntactically verbs that perform actions, and they can also share the same access modifiers. Now let's quickly design a simple class. Okay, we have a new project and we've created a sample class file. Say sample class.php. Now, if you're declaring a class, you start by using the keyword class. Let's just call this class math. And let's create just two variables. Let's call this x first variable var1. Okay, and then let's call this var2. Now we need to add a modifier, and in order to add a modifier, let's start with just the public modifier. Okay, and we also give the two public. Like I said previously, there are about three major modifiers. You have public, you have private, and then you have public, you have private, and you are protected. Okay, so the next thing here is I'm going to design a function method. Usually when you place a function like this, its default is public. Alright, so let's say nvar, let's call this nvar, and our parameters you can give it as f1 and f2. Now, we want to ensure that this thing has, we can access the variables declared here, because these variables are the properties of this class. This is the class name, and these are the properties, the one we call the adjective that describes this. Okay, now in this specific you have to put a dollar sign there just to ensure that that is in order. Now here we're going to use the object word this. When you use this in programming, we are referring to the class itself. That's the math class. Now, as you can see on the screen, the compiler is already giving us about two variables: the global variable, which is variable 1, and the second variable, which is variable 2. So what we're trying to achieve here is that we want to ensure that we can use these global variables that belongs to the math class. Okay, so now we're going to equivalent the first variable as 2. Then the second variable, this variable, is equivalent to 3. Okay, so then let's say F1, it should be F1 as the dollar sign F1, and then this F2. Let's call this F2. So we say echo, let's call our Z, let's create everybody called results, and see F1 multiplied by F2. F2, yeah. Now, we're going to just try and return this value here. Say echo. Alright, so I think we really have something. Now, what we just simply done is that we created a class called math and two variables with public access modifiers. Then we created just one function or method, and the function name is called nvar with two arguments, f1 and f2. Then we demystified the public variables that belongs to the math class, the properties. We assigned it to f1 and f2. So variable 1, the property 1, has now been mapped with this function, it's now been accessed with this function as f1. Then var2 is being accessed by f2. These are the arguments. Usually when we declare a function, in the brackets you have the arguments. Okay, so let's see how we can use this now. Alright, now we need to instantiate this class. Like we said earlier on, an object is the instance of class. So if we want to instantiate this, we simply declare a new variable. Let's just call this nmath. Alright, and say new math. Yeah. So we have now assigned a new name to this class here. So every function that belongs to this class is directly being inherited, is being transferred to the new variable, to this variable, the nmat variable. And this is a typical instance of course, inheritance. Is part of inheritance. So what we want to do right now is I want to just echo out something here. Let's say nmath nvar. So we need to supply these two. Let's call this 3. Let's give it 3. And of course you close the semicolon. Now we want to echo out multiplication or process these results and give us a value on return. So let's just quickly run this, and before we run that, let's ensure that we place this. Let's run this and see the outputs. Okay, so you can see the result now. 2 multiplied by 3 is 6. Now, how did we achieve this? We declared a math class, and then we declared 2 variables. Okay, this is a property, the adjective that describes the object. Then we created a function, just one function here that is called nvar, and then we assigned 2 arguments to this function. Then within the function, we now assign these 2 properties under this new argument belonging to this function. That's where we use this object. This object in PHP, and I think in Java, it is used for assigning another way of calling your class, with your current class, and our current class here is math. Okay, so this math to var1 as f1. Now you're calling an object property method. Okay, this is an object directly accessing its method. And like I said earlier, when you're referring to functions, you're also talking about methods. They perform actions. They are verbs. They perform actions. So the action we are asking it to use, and we're telling this object to call one of its functions, which is called nvar. Okay, this var belongs to the object. We are asking it to make the public variable that belongs to the math class as what its own. It's calling it to be its own. That's why we are saying it. The LHS here is being equivalented to the RHS. The same thing applies to this. Then the result, we now say the result should be the multiplication of f1 and f2, which of course, in other words, is still the variables belonging to the class. Now, down here we have a new variable name that is being initiated as the new instance, okay, of math. We don't want to use math directly. Okay, so that's why we're instantiating the new class here. Then we just simply say echo the new class name or instance of math class and call one of the variables, the variable that is here. That is the function variable here, the method that belongs to the class. Then the arguments. These arguments could be anything. If you change this argument now to maybe 4 and 4, we discover that now 4 and 4 will be multiplied. 4 and 4. You save, and then you run. Let's refresh this. Okay, so 4 by 4 is 16. You see? So this is just the concept of classes and objects. And let's now take a look at an abstract class. Now, what we should understand is that the features of an abstract class are as follows. It can have methods and properties just like any other typical class. However, it is not or cannot be initialized. Hence, a class is needed to extend it. Then an object of the class can be initiated or rather instantiated. Again, a class with one single abstract method makes the class abstract. Alright, and finally, declaring an abstract method is just the statement, the name of the method and argument, but the body is void. Now let's take a typical example here. I've actually composed this abstract class here, and when you're declaring an abstract class, you must begin with the keyword abstract. Okay, now the name of this abstract class is electronic switchboard, and we have certain variables here, or certain functions or methods. Like here we have the function on, and then here we have the function off, and then of course we have the function set switch with argument ID. Now each of them has just a singular output. For this has echo switch, light switched on, echo switch, light turned off. Then the object is being mapped to the switch, which of course is this property here that belongs to the abstract class. Okay, now we want to make use of this abstract class. How do we do that? We create a certain class, a child class here. This specific one says socket extends electronic switchboard. So it now says public function watt power. Now if you take a very good look at this function, this says watt power, and then the abstract class also has watt power. So there we have electronic switchboard as the main abstract class, and of course we have a socket class that extends. Extends is actually more representative or dictative of inheritance. So once you use the word extend after a class, you're definitely trying to perform inheritance. So this socket extends electronic switchboard, which of course is the abstract class, and that clearly indicates that every function or every method within the abstract class can be extended to the child class, which of course in this case is the socket class. Now, another important thing I want to draw your mind to or your attention to is that public function watt power is the first and only function of this class, and it is the link or the very abstract method that it is extending. Yes, it is extending. Now look at this. This is watt power, and then this is also watt power. Alright, so it shows that it is making use of one of the methods of the parent class, which is the electronic switchboard. Now the next class is the button. It says button extend electronic switchboard. So we have another function, but the same function that is coming from the parent class, which of course is the abstract class here. Alright, so then it also has its outputs. Now finally we have the instantiation. Like I told you, when you're instantiating a new class, you instantiate with a variable with a new keyword in the LHS, or rather the RHS. This is the RHS, this is the LHS. The LHS has the variable name, while the RHS has the receiving or transferring class. Okay, so when you click, you say new socket, we're trying to instantiate first child class here. Alright, and then we now say switchboard set switch to 130 amps x1 and break the line. Okay, this is the method class instantiated can be mapped to either a parent class or its own very method. Okay, the class that is instantiated can be mapped to its method or function. Okay, with the argument. So the actual thing is object. Let's say it's object dot properties dot method. This is actually the template for analyzing data objects. This is J. Okay, so you should just ensure that you know, get to understand the fact that this is how classes work and they call themselves. An object can call its property directly, and it can also call its method directly. You can also call both the properties and the method. So moving on, here we have the instantiation calling what power. Okay, now set switch is one of the functions of the parent class set switch method. That's why it's called set switch here. Then you have switchboard again calling what power. Then this what power is resident in the socket class. Alright, so then say finally switchboard on. This on is a method in the parent class, as you can see up here, is the public function on. So the instantiated object is calling one of the methods again of the parent class. So let's run these on the browser and see what it gives us. Okay. Alright. So on the browser now, we're having okay, yeah, let's expand this. On the browser now, we're seeing that we're having this is 130 amps x1. The wattage is this, and light is switched on. So we've seen that, of course, as the variable resistance, it has as a new object. Then the switch set is set to 130 amps. That's the set switch, which of course is the method in the abstract class. Okay, set switch, this is it with ID argument. The argument is given here is 130 amps. Then switchboard what power. What power is of course a primary method within the child class itself, which outputs this. Okay, what power is 155222 kilowatts. And over here we have the what power itself button. It has only one argument. If you look back at the screen, it's doing virtually everything. It's calling each method with respect to the class. So that's just about how to develop an abstract. Now the next thing we want to look at is the access modifiers. Now usually, or if you recall, I did mention that private, public, and protected are the three major access modifiers in use in PHP. Now private is when a private variable is property is declared in a class. Okay, no external class can access these variables, all right, except if exclusively localized through a function. I'm going to demonstrate what this means in the next few minutes. So here we have a class that is called state local government area, that's LGA, and then we now have two properties called private LGA and state respectively. Now the first method demystifies the first property here for local use. So you have function set LGA, LGA gov. LGA gov is the argument that this function is returning. So and then we now map the object property, this object property here, to the local one here, coming here, is equivalented here in the RHS. Okay. Now the next one sets the state. You see function set state, which of course is the second property here. So it's being localized by the use of the Okay, keyword this state, that's referring to this state here. Okay, so this is the object. Alright, so the object, the property, and then the assignment here, which is of course the argument coming into this function. Alright, then finally here under this class state LG, we have display LGA. Alright, so display LGA just has a singular output. It says my hometown local government state is this LGA, these states. Alright, so now in order to make use of this, we say we create a new instance of the class state LGA. Okay, access. Alright, so here we have S as access, that's the name of the object that is being instantiated. Now new state being assigned to S access. Alright, so here we're going to try to access the private variable of class. Okay, and then here we have state access, that's the instantiated access being mapped out to state. Alright, so and then finally we have SA access set LGA initial west, and then set access set state or show state. Now we already know what this is doing, because this is actually instantiating an existing object, and it is now calling one of its methods. Alright, let's now see how this runs on the browser, the kind of output it generates for us to see. Okay, now look at what it's saying. It's saying fatal or error or auth error cannot access private property state LGA in this. Alright, so in essence what this is saying is that we cannot access these private variables just because they are private and they are meant specifically for the parent class, this class in question. Any attempt to bring up or try to access the methods, these methods here, the methods belonging to this private class here, private variables here, will result to an error. Now let's now try and do the same thing we've done previously in a different way. We still have a private property here belonging to state LGA, but this time around this is not the first thing. This is property class. Okay, so we have LGA state here as a private variable. Now the next thing is we declared a function to set the state location. Okay, so now we have LGA state as an argument to set state location, and then we're calling the object's property here as what LGA states. Then down here we have public functions get state LGA, return this state. Now what this function is simply doing is that it is trapping this property here, alright, as a method, or rather, okay, so this public function gets LGA here, returns the object back. Alright, in this function, whilst the first one just sets the variable to a local argument here from this function. Now, if we are instantiating the object, we still do the same way that we've seen it being done. This time around, we give the name of the instantiation R access, okay, and it gives us an instantiation of the object class state LGA. Alright, so now let's now try and access a function to set the states. It's a state here, state and local government Okay, so here we are going to see our access setting location as what initial west or show state. This is supplying this argument, the argument of set state location. As you can see, this is variable for it. So when we're calling the function, we are supposed to return or rather to supply the argument in question. So we say our access set location this. All right, now you now say echo my state and local government is out. So what we're saying here is that we're expecting the program to just output my state and local government is initial west or show state. Let's just quickly run this on the browser and test its functionality. Okay, you see that now. So these are the two methods being called. My state and local government is initial or state. See, what helped us to achieve this is just simply instantiating a new object, alright, and storing it in a new variable called our access. Then we now call the set state location, alright, and supply these two variables together, the LG and the state and LG, or LG and the state, local government and the state itself. Alright, so and then we now say echo government our access get state LG function. Okay, so this function helps us to return both the state and the local government. Alright, and we achieve this and in contrast to the other side where we could not access because of the private declaration of the variable. This, what has enabled us to achieve this is simply the using of localizing this particular property which is private. We localize it, okay, by setting the state location, states using the this object as an equivalence of the function argument. Then, of course, you're returning a function, you're declaring a return function that actually returns this variable here, the property here, which is private, which is not accessible to any of the thing. Okay, now assign it to what the LGA states. Okay, saying it should return the value assigned to it. That's what this means. And that's how simple it is to differentiate between private and public class. The next thing now is to look at protected access modifier. Now, in protected access, when we're declaring protection for variables, we also have the rules of accessibility. We can't just call protected functions or properties directly, except if you try to localize them after using the keyword extend. Now, in this instance, or in this example, we're looking at a class that is called human body. Okay. Now, we have protected compartments being declared. This compartment is a direct property of the human body. Alright, the human body class. Then we assign an array, like we said previously, initialized at 0, 1, goes increments forward. So in this array we have heart, soul, and mind. And in the first method belonging to the human body class, you have function get human body attributes, compartments. Now take note of this specific labels and how they link to each other. Now we now declare the sequence. This is a sequence, or rather alternate. Yeah, this is an alternate sequence. Okay, to check on the variable if the variable is equivalent to heart, to soul, or to mind. If it is heart, then there should be a string output that you see from the heart process the issues of life. And if it is soul, you see the human soul is everlasting. And then if it is mind, then as faces are different, so are the minds. Okay, so this is the only method that this class carries. Now, going forward, we now create a subclass or a child class called human anatomy that extends human body. Now, you see it has protected compartment heart as well. We now create a a variable to a variable function or method. Alright, it says get heart length compartment, and what it has within its block of code is that it is initializing compartments as compartment. That is localizing this variable here, this one here, is localizing it as its own for its own use. So this is how it does. It says this compartment equals compartment. Then this get body attribute is also calling the second attribute, which of course is protected. You know, the reason why it's beginning to access the method of this class because it has used the word extend. So then the next thing, we now make an instance. Alright, we make an instance, and the new instance is the instance of the human body. Then the HA is the new instance of the human anatomy, respectively. That's the parent and the child classes. Then over here, now we're going to tweak. Now I placed some things in comments here. Of course, you could try. If you try this, call this, it will not. Let's keep that. So what we're saying in SA now is that with the instance of this class, human body anatomy, if what we're expecting is that if this displays, then the variable that is in the source section should appear. If you change the variable there, of course, which of course is compartments, then it should now change to the respective string that has been assigned. Okay, and don't forget this particular method here belongs to the parent class, but now it's being used and it's, you know, it's a protected function, or it's a protected variable. So the only way we are accessing that is because the child class is using the word extend. So we can, and then we're also having its own property to be declared. So let's quickly run this now and see how this goes on screen. Let's say we say take this in the browser. Okay, so you see the human soul is everlasting. Now if you change this to heart, okay, save and we want to refresh this page here. Okay, from the heart process the issues of life. Then if you change this to mind, and you save and run, mind is capital M, not lowercase. That's right, that one is blank. So we have to ensure that we are referencing our variables in the right format. So let's run this. Okay, our spaces are different, so are the minds. So what we've successfully done now is that we've been able to access a protected property and method or function, okay, in a new class called human anatomy. Alright, and we've successfully. Now let's take a look at the constructor class. We want to see how to use constructor function or method rather. Now in PHP we have constructor and destructors. Okay, so right here we have a class that's been declared called computer system. Then we declared two variables here that is called private Dell system and private HP system. Now the next thing is that we now create a constructor method which starts off or initializes the properties. Okay, so here we have function constructor. This is how to make constructor. You place two underscores together and then you write construct. Alright, so now we have the constructor method has two arguments, Dell laptop and history laptop, and we want it, once the function is called, we want it to echo starting up object. Okay, now we now localized this property Dell system, which of course is private. We initialized it or we assigned it to the local function here. Right now, Dell laptop and HP laptop respectively. Then in the next method, we see display system type. Okay, echo the computer system type for Dell is this del, which of course is the part is referring to the properties of the class directly, and this HP system. Alright, the same HP system we see here. Now we instantiated this class, the new computer system class. Okay, so we immediately assign arguments to the computer system. Okay, so del intel icon, this and system instance display system type. Alright, so this particular instantiation is calling the display type. So what we're expecting is this string will be echoed out with respect to this argument being supplied to the class itself. Okay, let's just run this and observe what goes on the algorithm. Okay, so you see that it says this is the first method of the class itself. So starting up updates. Then these are the arguments. This string is declared by the second property, rather than the second method. So you see computer system type for Dell and HP is Dell Intel iCore 7 10th generation, and HP Intel iCore 7 10th generation 17 inches. So this is how to use the constructors. The constructors are actually used to initialize. Alright, okay, initialize variables and display what is meant to be a startup. That's just what constructor function does within a class. Okay. On the flip side, we have a destructor class as well. Now we've seen the use of the constructor class. Now this is the destructor class. The destructor class simply say cleans up resources or does something else. Alright, so we can say obliterating objects. Okay, this is the first method here under the computer system 2. Now the next method is display object properties. Okay, the computer system function is this and this. Now the destructor simply just destroys or discards the entire initialized variable. Okay, while the constructor builds it up. Alright, so let's just quickly see this, how this works. Now we've initialized the object through the computer system using new, okay, to instantiate a new variable of it, or a new string of it. Now we say we now assign, just as we did previously, we assigned these two variables to private properties here. And what we're showing is that to display object properties here, okay, while also outputting this struct variable function or method. So let's quickly go to the browser and see how that works. Okay, starting our computer conversion is this obliterating object. So you can see that after starting it up and initializing it, it also obliterates it by calling that particular struct function. Alright, so this is just how its constructors are used for building and starting up, while destruct functions are used to discarding object variables so that the system resources can be freed up. Now let's now take a quick look at inheritance. Now the structure of one of the very popular features of object-oriented programming is inheritance. And inheritance means that certain aspects can be transferred to new instances. Certain methods can be called from a new instance. Alright. Now for this particular example, we'll be using the family. Okay, we declare a class of family and we set the property name as father, as public father, as you can see here. Now, public, of course, like I said previously, public is a keyword access modifier that makes the variable declared accessible from anywhere, both within the class, the parent class, or any other class outside of it. Okay. Now, public function work, right? We are declaring the I function here, not actually work. I comma here. Alright. So here we have the function. The first function says echo this further. Okay, it's calling up this variable here that belongs to the class. And this further is brown. Okay. Now the second one is I color. Further's texture is black. Right. So here we have two major functions and a singular property belonging to the family class. Now we declare two specific child classes. The first one is son class that extends family. Like I said, once you use the keyword extend, it makes all the variables declared in the parent class accessible to the child class. Now there are two child classes. The first one is the son, and the second one is the extends family. Okay, the daughter extends family. Both of them extends family actually. They don't have any specific methods or functions declared. But now in the new instance, we now create a new instance of the son as new. So now son child. Then we declare another, of course, instance or the same instance of son child, mapping it to the father as my sons. Okay, then it's calling one of the functions there. Okay, it's calling father directly the property. Alright, as my son. Then daughter child is also instantiated as new daughter. Okay, then you have the daughter child calling the father, so just like the son is calling the method of the father. Okay, and this one is being assigned my daughters, while the name for the son is my sons, as you can see here. Now over here we now bring up this daughter child I call. Alright, we are calling this daughter child class, instance of class is being called, is calling one of the methods of the father directly, which is the icon. So then the son is calling the color method. So each of them takes one. One calls the method called color, and then the other one calls the function called icon. Now let's run this and see the output. Alright, so on the screen now you see my daughter's eyes is brown, my son's texture is black. You see that now. So this is how inheritance works. It simply takes methods or functions of a class and uses it as its own. And this is made available by what the keyword extends. When we use extends, it shows that you're preparing the parent or the child class to make use of the parent functions or properties. Okay. In other words, all the properties and all the functions or methods of the parent belongs to the child. And of course, that is true as well. Closely related to what we just concluded. We declare, I want to look at another way of seeing inheritance in practical use. Now we have a class called Computer OS, and it has just one property called Public Operating System. Alright, now over here we have the function set start, and then we have another function called set stop. In the first method, we say it should echo out this operating system, initialize startup. In the second one, we say it should the update word, say operating system kernel shortly down. Alright, now we created two major child classes. The first child class is called Linux OS, which of course extends computer or system OS, this parent class here. Then the second one is a child class that extends, of course, the same parent class, computer OS, as you can see here. Then, of course, it's expected to inherit everything in the parent class. But we didn't put any method here anyway because we want to focus on the Linux OS. So in the beginning of the instantiation, we now create a variable that holds the new instance of the Linux OS class, which of course extends computer system OS. Then in the second line, an instantiated object should now call operating system. It should rather should refer to the property which operating system here. Look at it here. This is the operating system in question, the major property or variable of the object computer OS. Alright, so we are assigning it a new variable called Red Hat. And this is legal as far as object-oriented programming is concerned. Now, calling the parent class method. Now, Red Hat, of course, we know Red Hat is the new Linux OS class, is the instance of it. So you see, Red Hat, after assigning it, you should set stats. And what is set stats? Set stat belongs to the parent class here. Alright, just as we saw previously. Set stats, and it has a return value here. If you echo this, then finally we see Red Hat boot. This is the Red Hat boot. Red Hat boot is a function that belongs to the Linux OS directly. Okay, so let's run this and see the output. Okay, you see that now? This is Red Hat initialize startup. The second line is Linux Red Hat. And the last line is booting up the node desktop. So simply, what this has done is that the Linux OS has made use of one of the functions of its parent class, which of course is the set stats. Okay, this operating system initialize startup. I can see initialize startup. This is the major operating system initialize startup. And the second one here is assigning, of course, the variable to this variable to it, which you've seen here. This is the Red Hat. Now the second line here is the set stats. This is set stats here. This operating system initialize startup. Okay. And then the Linux Red Hat. The Linux Red Hat. And then the boot. Red Hat boot. The Red Hat boot is the function. Red Hat boot is the function that actually is resident in the computer OS, extending the Linux OS. Okay, so that is just about how to use inheritance, and the concept is being able to use a parent class. Okay, extend the features. The features, of course, are the variables of the property and the methods to the child class. And this is a very useful feature in not just PHP. Now, please note, if a child class inherits a parent class, access is only granted for the non-private properties and methods. Therefore, it is advisable not to use public access modifiers for the properties, as then the properties would be accessed from outside of the class too. In other words, what we're saying is that in order to permit a child class to access properties and methods of the parent class, okay, a protected access modifier should be utilized. If any property or method of a class is protected, then those properties and methods can only be granted usage within the child class, which inherits the class. Now, this is what we're talking about. We have a parent class here, and it has a property called analytic ability that belongs directly to the father class. Now, we create a sum feature here. A sum feature with just one output variable. Then a function daughter feature with just single variable. Now, we now create two child classes here. The one is the sum, the other is the daughter. The son class, which of course extends the father, has just one variable method called the son feature. It's a solving linear algebra from son inheritance father method. Okay, so class of the daughter, which of course extends the father as well, so it's function daughter feature and echo solving geometric progression from daughter inheritance father method. Okay, so we create a new instance of the son as son instance. The new instance helps us to call analytic availability and set. This is the variable, the property belonging directly to the father, as you can see here. Analytic ability. Alright. So analytic ability is related to algebra. Now, you now use the son now to call the son feature. The son feature belongs to the son itself, which extends the father class. Okay. It extends the father class. Then a daughter instance, which of course extends the father as well. Okay, now also has access to the father property, which is an analytical property. Okay, so here we have solid geometry. The son has assigned its own instance to algebra, while the daughter's instance to the father's properties, solid geometry. So we want to just ensure that both the son and the daughter features are outputted to the screen. Alright, the son instance of the son class, calling it the son feature, and then the daughter class, calling it the daughter feature. Both the daughter feature and the son feature are individual methods within the class. As you can see, this is the son feature and then this is daughter feature. Let's quickly run this and see the outcome. Alright, so you can see that now it's solving linear algebra from son inheritance from father method. Okay, then solving geometric progression from daughter inheritance from father method. So this is how very simple inheritance we protect. What we should just know is that the moment you declare a private or public property, okay, and you have functions within the parent class, okay, the moment you want to call or make use of a property that is private or public that belongs to parent class, you need to use extend, and the extend keyword actually pragmatically brings inheritance into play. Alright, so for the fact that we created this variable either private or public makes it inheritable, alright, such that the son class can call any of these properties that belongs to the parent class, or even including the methods and the functions. And like I've said earlier, the methods can also be public or be private, otherwise. So the moment you have this in the back of your mind, then you can conceptually approach programming in object-oriented style. Okay, so now in this next class, I want us to take a look at using classes and objects to connect to MySQL or SQL. Alright, so now we have a class here being declared. It's called dbconnect, and we created several variables here. Private, of course, because this has to do with sensitive information. We declare the host as this, and then we also declared db user as root, then private password, just like we did previously in our control management system, which we did in the previous video. Alright, so now private options now is declared as an array of the attributes mode being mapped now. What is being used here is an associative array. Alright, as PDO attribute error mode is being mapped to PDO. Then of course the exception. Then the PDO attribute before fetch mode being mapped to fetch ASOC. Alright, then please you have to make sure that you put your columns and the likes in the proper position, otherwise you'll be encountering errors. Alright, now we now declare the protected column. Alright, you see the use of protected now. When you're connecting to database, private, you don't have to declare your information as public, because a hacker or somebody can just hijack that particular mode and use it to work, and you don't want that with you. So that's why we're declaring all these as private and these as protected. Now look at this. We declared still under the DB connect, we now declared a function. This is a function. This function, its task is to use the try and catch that you've seen previously in the video. Try and catch is of course part of the new PDO method of connecting. So now what it does is it tries this column. That's its column. That's the property. Column is a property of PB connect class. Alright. So now we are asking we are directly referring, making a reference to the property of this class, which is column, as new instance of PDO using this host. That's this host here. Then this DB user, of course, this DB user here. Then this pass here, and of course the options. These are the options. Alright. So then we now say return this collection. Yes, you return value. Now the next aspect of it is just catching. See, catch PDO exception the connection failed if there is any issue with these variables. Alright, then the other function that comes under last the DB connect class is the MDB connect. Alright, so we can actually terminate the connection with this. Now in the next part of the code, we create an instance called the new DB connect, just as we've seen in the previous descriptions of classes, methods, and objects. Alright, now here we now in the new instance class, make a new name, which of course inherits all the properties and methods with DB connect. We now say connect DB. Now if this goes well, we should not find any error. And if there's an error, then this particular part of the code will come into play. Let's quickly run this now and just see how this is demonstrated. Okay, so you can see the screen is blank, and if the screen is blank, it means what we've constructed in this class, the DB connect class, is 100% working. It has successfully instantiated, and it has also called the DB connect successfully. If for any chance there's any problem here, or having to put something that's not going to be there, and you refresh this program, you see connection failed, SQL states access the is telling you where the error is from. You place the password where it's not supposed to be. Alright, but in the absence of that, in the absence of any error, okay, and you run, yeah, you have a blank screen. So what makes the error come forth is this catch error section. Okay, you don't need to put if it is common again, because this is no longer necessary. This is what captures the error, if there is any.